Hey everybody, this is Barney Fife, and this lesson will be on graphing exponential decay functions. So we still haven't got to logarithms yet. We're almost there. Let's go ahead and graph. We did exponential growth functions in the last lesson. So let's do a decay. So let's go ahead and graph each function and state the domain and range. And I skipped this one in the exponential growth. So it's the same thing. It'll be explained here, you guys. So okay, so graph y equals 1/2 to the x. Okay, now the reason why this is a decay is because this thing that's being raised to the x power is between 0 and 1. And if that's between 0 and 1, it's going to be a decay function. Okay, so, and then we'll graph, and it's an exponential function, you guys, because the x is in the exponents part, you guys. If you graph like y equals x squared, where 2 is in the exponent, that's no longer an exponential. That is called a power function, and that's a different topic. So this one's called the exponential function because the x is in the exponent. Okay, I'm going to start off by graphing a t-chart. Okay, we did this at the beginning of the growth function on the last lesson. So when I plug in -2 right here, -2 goes right here, and when you have a fraction being raised to a negative power, you flip the fraction and it becomes a positive power. So 1/2 to the -2 is the same as 2 over 1 to the positive 2, okay, which is 4. 2 squared is 4. So when x was -2, I go to the left 2 and I get y equals 4. So I go up 4 right there. Okay, when x equals -1, 1 over 2 to the -1 is the same as 2 over 1 to the positive 1, which equals 2. So to the left 1, up 2. When x equals 0, everything to the 0 power is 1. So 1/2 to the 0 power is equal to 1. So there's 0, 1. 1/2 to the first power, 1/2 to the second power is 1/4. Okay, so there's my exponential decay function, and it'll be connected up right there. Now, your domain is how much this graph goes left and right. This one goes to the left. Even though it's going up and to the left. It goes to the left forever. It goes up forever. It doesn't go down forever. It goes down to right here, and this line right here is called an asymptote. Okay, maybe you've heard of asymptotes before, and it's an asymptote, and this graph will never cross that asymptote. So y, which is your up and down movement, y never goes down below this line right here, so we're going to say y is greater than 0. So your domain is all real numbers because it can go to the left forever and it can go to the right forever. It goes up forever, but it doesn't go down forever. It goes down and asymptotically gets close to the x-axis right here, which is y equals 0, so it's y is greater than 0. Okay, that's your domain and range. Okay, so now let's do this one. I'm going to do the 0, 1 trick. So the 0, 1 trick, if you don't know what I'm talking about, please go look at section 7.1, and it says graphing exponential growth. And it explains this. It's a real quick shortcut, you guys. So when x equals 0, I plug in 0 right here. So it's going to be to the 1, 2 times 1. 2 times 1 is 2. So I'm going to graph 0, 2, and then when x equals 1, 1/4 to the 1 is 1/4, and 2 times 1/4 is 1/2. So there they are. That gives me my idea of my graph, and it's right there. So again, this one is your domain is all reals because it goes left and right, and your range is it's greater than 0. Okay, let's try this one. Okay, I'm going to do the 0 trick again, you guys. So 0, when x equals 0, anything to the 0 equals 1. -3 times 1 is -3. And when I plug in 1 right here, I get 2/5. So 3 over 1 times 2 over 5, well, -3 over 1 times 2 over 5 gets me -6 over 5, which is -6/5, which is -1 and 1/5. So just past -1 right there. Okay, that gives me a general idea. There's the graph right there. Okay, now this time, you guys, your domain is still goes left and right forever, goes to the left forever. Even though it's going down faster, it's still going to the left over here, and it's definitely going to the right forever. It's going down forever, so but it's not going up forever. So we're going to say y is less than 0 is your range, and your domain is all real numbers. Okay, all right, so let's try one of these guys. All right, remember, this moves my origin to the left 1, down 2. Okay, some of my kids think it's easier to just say opposite with what's x, and this is the same right here. So this is +1, so we go to the left 1, down 2. It moves the origin, you guys. So go ahead and move the origin to the left 1, down 2. and then we're just going to graph y equals 3 times 1/2 to the x. I no longer need this plus 1 minus 2 stuff because I fixed it with this moving the origin. This is not the origin, but pretend now that that is the origin, and just graph these guys. Okay, 1/2 to the 0 is 1, 3 times 1 is 3. So I'm going to graph 0, 3, which is going to be right here. Okay, so 0, 3. All right, and then when I do 1, 1/2 to the 1 is 1/2. 3 times that is 1 1/2. Okay, remember this is my new origin, so over 1 up 1 1/2. Okay, so that really has ordered pair 0, negative 1/2. But okay, and then so there's my graph, and so it's going to go down like that. Okay, so now my range is all, my domain is still all real numbers, but my range is y is greater than that -2. Okay, so now here's exponential decay, and they follow this equation right here. So y equals a times 1 to the 1 minus r to the t power. Okay, a is my initial amount. This is my final amount right here. Okay, I didn't write that, but y is my final amount. And then r is my percent decrease, and t is time, typically in years. All right, so so a new snowmobile cost $8,500. The value of the snowmobile decreases 7% each year. Okay, so what is the value after 3 years, and then approximately how many years will it be worth $4,000? Okay, so after 3 years, all I'm going to do is plug in a 3 right there. And my 0.07 is going to go right there, so it's going to be my initial amount, 8,500, 1 minus 0.07 to the 3 power. Okay, so 1 minus 0.07 is 0.93. 0.93 to the third is this decimal, 0.804357. And in that times the 8,500, it's going to be worth $6,837.03. Okay, so now on this one, in approximately how many years will it be worth $4,000? So that would be my final amount, you guys. So my final amount is going to equal my initial amount. And then this is my 1 minus the 0.07. It's the same as this up here, to the t power. Okay, so I divided both sides by 8,500 right here. Okay, so I get the decimal of that, and that's 0.4 something, 0.4706. All right, so 0.4706 equals that 0.93 to the t power. And we need to learn a little bit more about logarithms before I can solve for that t. In the book, they want you to graph it and then estimate, you guys. I'm not going to do that to you here because there's a faster, more efficient, exact way to get what t is in just about 2 or 3 lessons away. Okay, and I think, yeah, that's it.